So much like the previous topic, this topic will also talk about compositions of functions, but the examples that you'll see in this particular lesson will all just be rational functions. To refresh your memories on what function composition is, the first and second bullet point, function composition is just literally taking one function and substituting it inside of the other. Now, the important thing about function compositions is knowing what the overall or the new domain will be. And the idea, third bullet point, is that the domain of a function composition is the intersection or the overlap of the domain of the inner function, whatever you substituted, and the domain of your final answer. So, in this topic, the examples that you're going to see or the problems you're going to face are just slightly, not much, but slightly more involved. Let's take a look at an example here. Suppose f of x is 1 over x minus 4, and g of x is 11 over x. Find fog and simplify and find its domain. So by now, I'm pretty confident you guys can do the actual composition. It's just substitution. What I wanted to talk about was the simplification part and the domain part. So let's do this problem then. So fog of x is taking the g function and substituting into the f wherever we see an x. So we have 1 over 11 over x minus 4. Now this creates what is known as a compound fraction. Let me go ahead and get rid of the parentheses because nothing's multiplying it. The technique of simplifying the compound fraction is called clearing the fraction. You want to multiply every single term in the expression by the lowest common denominator. Now in this case, we only have one denominator, this x here. So we're going to multiply every single term by x. The 1 gets times by x, this fraction gets times by x, and this 4 gets times by x. What happens is all of the inner denominators should cancel. So let's simplify. In the numerator, 1 times x is x over, in this particular instance, hopefully you can see that this x here cancels out with that x there, giving us a regular 11 minus 4x. There you go. That's it. You've done it. You've simplified. So there we have fog. Now I need to find the domain. To find the domain, you find the domain of the inner function. And what was the inner function? We plugged in the g, so that's 11 over x. So we can see it's a fractional function, and then to find the domain of a fractional function, we just set the denominator not equal to 0. Well, that was pretty simple. Then we do the domain of the answer function. So the answer function was x over 11 minus 4x. And again, the idea to find the domain of a fractional function is to set the denominator not equal to 0 and then solve. So I'm going to add the 4x over, divide out the 4. So we get 11 over 4 cannot equal x. So what is the overall domain? So you have to start with the number line, and you have to imagine everything being shaded. And then you just simply incorporate these statements here. What does x does not equal 0 look like? What does x does not equal 11/4 look like? Well, if we were to mark them on the number line, here's 0, say, I think 11/4 is somewhere over here. What we're saying is at those spots, we cannot shade. So we have to imagine there's like holes or erased marks at those regions. So there's a hole at 0. And there's a hole at 11/4. So our domain would be these 3 individual pieces here. And then all you have to do is write them in interval notation. So our overall final domain is negative infinity, comma 0, union 0, comma 11/4, union 11/4, comma infinity. There you go. Let's just do one more example just so you have more than one example in your notebook. Let's say, f of x is 2 over x plus 3, and g of x is 7 over x plus 1. Fine. Let's keep up with fog and its domain. So, to find fog, fog of x, that's taking the g function and substituting it into the f function. So that's 2 over 7 over x plus 1 plus 3. We can sort of get rid of the parentheses because nothing's adding or subtracting it. Or actually, because nothing's multiplying it. And then we go ahead and simplify. To simplify again, you clear the fraction. In this case, we only have one denominator, x plus 1. So every single piece gets multiplied by x plus 1. So I just multiply everything by x plus 1. So in the numerator, you distribute the 2. That's 2x plus 2. Here we can see that the x plus 1's cancel, so we're just left with the regular 7. And then distributing the 3 gives us 3x plus 3. Which simplifies to 2x plus 2 over 3x plus 10. So that's fog. Now we need to find the domain. So to find the domain, you need to do the inner function. What did we substitute in? It was the g, 7 over x plus 1. So hopefully we can find the domain. Just set the denominator not equal to 0. So we get x cannot equal -1. And then we find the domain of the answer function, 2x plus 2 over 3x plus 10. So you set the denominator, 3x plus 10, not equal to 0, and then you solve. Let's subtract the 10 over, and then divide out the 3. So what would be the domain? You would just graph both of those guys on a completely shaded number line. And let's see, let's say -10/3 is here. Let's say -1 is there. And since my domain cannot include them, it's as if there are open gaps there. So once more, our domain will consist of 3 pieces. This left piece, this middle piece, this right piece. We just have to write it in interval notation. So our domain is -infinity, comma, -10/3, union, -10/3, comma, -1, union, -1, comma, infinity. So you can see here how the composition of 2 rational functions, it's the same concept, just plugging one function into the other. It just means that when you find your domain, there's going to just be a little bit more interesting stuff happening. That's this topic.